All right, now that you've completed the investigations, let's take a look at the conjectures that you wrote. So the first one, if two angles form a linear pair, hopefully you discovered that then the measures of the angles add up to 180 degrees. You could also say that then the angles are supplementary, which implies that their measures add up to 180 degrees. For the second one, the vertical angles conjecture, if two angles are vertical angles, then the angles are congruent. So what I want us to do together with me is to write a deductive argument for why the vertical angles conjecture is true, as long as we accept that the linear pair conjecture is true. So there's a reason that we complete these conjectures in order, because as we started off with our undefined terms, then we could use those undefined terms to define more terms, and the same thing's happening with these conjectures. We're proving each conjecture along the way, and we're using previous conjectures to prove future conjectures. So we're going to start. I'm going to give us a blank page here. So to start off our deductive argument, we need to set up the condition, right? The given. What are we given? So we are given two lines that intersect and form angle 1, angle 2, angle 3, and angle 4 as shown. Okay. Here's our two lines and our angles. 1, 2, 3, 4. So you can actually start this a couple of different ways. What I'm going to do is I'm going to show that angle 2 is congruent to angle 4 because they are both vertical. And then you can actually repeat the process to show angle 1 is congruent to angle 3. So once we have our setup, the hint here is to use the linear pair conjecture, and we're going to start with that. So by the linear pair conjecture, what did we just say? The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And so again, since we're trying to prove angle 2 is congruent to angle 4, I need to get an angle 4 in there. I already have an angle 2. What else forms a linear pair? Angles 1 and 4. So, and the measure of angle 1 plus the measure of angle 4 is 180 degrees. So I had to use the linear pair conjecture twice. Once here with angles 1 and 2, once here with angles 1 and 4. Can you see where we're going with this? Since both statements equal 180 degrees, we can say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 4. They both equal 180, which means this must equal this. Subtracting the measure of angle 1 from both sides, which is our subtraction property of equality, what are we left with? The measure of angle 2 equals the measure of angle 4. Now you might think we're almost we're done, and we almost are. The thing is we're trying to show that those angles are congruent, not just show that their measures are equal. So what we can do is we can use, by the definition of congruence, the measure of angle 2 is congruent to the measure of angle 4. So we can't just stop there and say the measures are equal. We have to take it one step further and say the angles are congruent. But we know the angles are congruent because their measures are equal. And that's the definition of congruence. And we're done. So take a minute to digest that. Rewind it, pause it, think about it if you need to. And when you're done with that, I want you to go ahead and look at those 3 example problems below and apply our linear pair conjecture and our vertical angle conjecture and actually find the measures of some missing angles.